Okay, so what I just thought I might do now is just go through some examples. I know I said in my last screencast at the end that I was going to leave that to you, but I thought that it might be helpful just to go through a few of them. So I'm working from the examples on page 184 and 185, just leading into exercise 3F, which is going to be our next exercise, our next task. Okay, so let's have a look at example 13. So we're looking at simplifying these expressions. So x to the 5 times x to the power of 4, and I think we can all safely assume that we know what we're doing here. We add the 5 and the 4 to get x to the power of 9. However, when we have some numbers involved, so it's 3a squared b times 4ab cubed, what happens here? Firstly, we need to take the 3 and multiply by the 4 to get the 12. Now we go looking for the algebra. We've got an a squared times a. Now that little invisible power is a 1, and I'm multiplying same base, so I add the power, so it'll be a cubed. It's a great idea, again, if you pause this, write down or say the result, and then press play again and see if we match up. Again, you had a little invisible 1 there for the b. b times b to the power of 3 is b to the power of 4. So that's how we would do that particular example. Okay, going to some division examples. So m to the 7 divided by m to the power of 5. So we're straight in here with just m to the power of 7 minus 5, 2. And then a more challenging 4x squared y to the power of 4x squared y to the power of 5 divided by 8 xy squared. Okay, so in this case we're taking the 4 and we're dividing by 8, so that's going to be 1/2 x squared divided by x, so again a power 1 there, subtract 2 minus 1 is 1, and now y to the 5 divided by y squared, so we've got y to the power of 3 there, doing a subtraction of powers. Okay, moving along, we're looking at an example now of simplifying a cubed all to the power of 4 using that index law where you take a power to another power, you multiply the powers together, so that's a to the power of 12. If we've got 2y to the power of 5 all cubed, so 2y to the power of 5 all cubed, so we need to just look at what we do here. In this case we've got a number at the front, that's also got to be cubed, so it's 2 cubed, which is 8, y to the power of 5 cubed. In this instance we just multiply those powers together, so it's 8y to the power of 15 as our result. Another example here, a slightly more complex one, 3x squared over 5y squared z over 5y squared z, all raised to the power of 3. Okay, so a good idea here is to do that split. So we use that index law here where we split the fraction up to top and bottom, and we raise both to the power of m. So in this case we're going to say, well, let's take this 3x squared, raise it to the power of 3, and if we do them individually it's a lot easier. So we just do that split first, and then we say, righto, 3 to the power of 3 is 27, x squared to the power of 3, multiply those indices together, 2 times 3 is 6, so 27x to the power of 6, that goes over 5 cubed, which is 125, y squared cubed, right, that 2 times 3 is 6, y to the power of 6, z cubed, z's just power 1 there. I think that's probably the best we can do with that. And finally we're just going to have a look at another example here where we look at 4a to the power of 0. So now if we can look at the 0 power, that's just equal to 4 times 1, because this naught is only associated with the a. So the a to the naught is 1, 4 times 1 is 4. So that's our result there. And just one more example, 2p to the naught plus 3p to the naught. Now this one's going to highlight that little situation where 2p to the naught, that's equal to, p to the naught is 1, so that's just 2 times 1 is 2. Now this whole thing's raised to the power of 1, so this whole thing is 1. So 2 plus 1, our result there is 3. Okay, I think we're now good to go on exercise 3F. So refer to your work requirements, and we can get stuck into that. See you Thursday.